My name is Avery, and today we're going to be covering concepts to learn programming. So if you guys have never programmed before, this video is for you. And if you guys are wanting to learn a new language, this video is also for you. Most programming languages, they have some similar things in almost all of them. So we're not going to be looking at any specific language. We're going to be talking about topics and concepts that are used in all languages. We're not going to discuss how a computer works too much. We're going to discuss a little bit about memory, but it's nothing too complex. So just to get started, programming, basically, an easiest way to put it is logic and arithmetic. It's basically just what you learn in a math class, like even math in middle school, or even before that, such as like 3 plus 3 equals 6. So here we have our values, and then here we have our operators. And basically the arithmetic is just to solve something. You give it something and it solves for something. And that's all what programming, that's all what computers do, really. You tell it something to do and it does it. So if you want to know how to program, that's basically all you need to know to get started. Just how to do some basic math and understand some logic. And outside of just doing numbers and operators, such as the plus and minus and division, the programming language has something called variables. A variable is just like what you learned in math, probably in like algebra class, or x, where the x can represent a number. So we're going to have x represent 3. So every time we are going to do some math with x, we can do x plus 7. It's going to know that x is 3, and that's going to be 10. So programming works the exact same way. You'll have a variable, and you can assign it to something, and then you can use that variable whenever you want. One example is, say you have pi. There's no character for pi, but say you write out pi, and you do pi equals 3.14. And now anytime in your program that you want to use pi, you can just refer to pi instead of typing on pi. And it's as easy as that. Variables can also be reassigned. So now we can assign x to 11. And now if we were to do x plus 1, we're going to get 12. So it replaces this 3 with the 11. And we're going to be talking about other types of variables and also what you can do with these variables. As of right now, this x is an integer. An integer is basically a whole number. This is the term used in, well, outside of math, it's the term used in most programming languages, an int. And an integer will just be a whole number. Let's say you want to have something that stores a word, or a character, or a letter. Say you want x to equal to hello, instead of being a number. So anytime you want to refer to x, it's going to be hello. And this hello is usually referred to as a string. A string is a string of characters. A character by itself is usually just one of these single letters. And a character could also be different things, such as anything else that's on your computer. The pound sign, the hashtag, an at, basically anything out there. They're all configured a little bit differently, but that's the main concept. A character is a single letter, and a string is a string or a combination of these characters. And like I mentioned before, an integer is usually a whole number. So what happens for pi, for example, if you want to have 0.14, how are you going to get that 0.14? Programming languages have different options as well for variables. One of them is usually referred to as a double, and one is referred to as a float. Doubles and floats, we're not going to cover them too much on how they work, but they have a way just to know that there's a decimal point and what's beyond it. They have different precision and whatnot. Say this is a really long number that goes on. As we know, pi goes on forever, basically. A float and a double will try to store this information, but as it tails off to the end, it'll lose a little bit of the information. But it's not too much to make a difference. It's basically just as much as you would do in real life. And now let's say you know that your variable is an integer. My bad. Okay. So you know your variable is an integer, and instead of telling the computer that it's going to be an integer, there's usually an option for using auto. So you do auto, and then you give it a 1, it's going to know it's an integer. Auto 0.1, it's going to either tell it's a float or a double, or if you were to do auto C, it's going to know it's a character. The same with X. And then if you were to do something like this, it's going to know it's a string, even though it says char. It knows it's a string because it's made out of all these characters. And most languages have this feature of auto. And along with that, there's something called constants. A constant, I guess this is used in math and science as well. It basically is a variable that you're telling the program that you're not going to change. If I were to do const pi, and we set that to 3.14, by declaring constant, we're telling the computer that we're not going to change this value. This is important because sometimes there will be programs that need a value and they want to make sure that there's trust between you and the program, so they want to make sure that the value is a constant and they don't want you to change it afterwards. And depending on your programming language and depending on how you're doing it, you usually can't change a constant. There's another concept for casting. Casting is basically changing something from one type of variable to another. Let's say you have an integer. Let's say this integer is equal to 1. You want to cast this to a string. So now let's make it a string. And now it's basically just going to be this right here. You can't do math with it anymore. It's just a character. But also on the other hand, let's say you have a string that is 320. And then you also have an integer that's a 2. And say you want to do, let's call this one x, call this one y. Let's say you want to multiply x by y. These are different variable types, so they don't actually work. Plus you can't do multiplication. Usually you can't with a string. So to do that, you're going to have to make this x into an integer. So this concept is called casting, where the x now becomes an integer and then now it can do the multiplication. Now, just a brief moment, we're going to be talking about memory and how it works on your computer. Let's just imagine the memory on your computer is a grid, and in this grid it stores values. So let's say this is where x is going to be equals, and this is the value of x, and this is y is equal to 20, and dot dot dot. It just fills in every single spot in the grid. So anytime you want to refer to something, you're going to have to know where it is in the grid. So basically we can say that x is represented here, but the value of x is here. This is a very a brief explanation of it. This isn't exactly 100% how it works, but basically this is saying the value, the variable name, its data is somewhere in the memory. There's different ways that memory can be stored. One concept is called stack memory, and this is when, say, you create an integer, let's call it x, and then you set it to 0. When you add this to your memory, it's the first thing to go in. So this is your grid, and say that x will be placed right here. And then if you were to create y, say y equals 5, then y is going to be created right here. This is a concept of stack. A heap, on the other hand, heap memory is kind of random, or say you have y equals 0, and this is in the heap. Since all it needs to know is where it is in y, it doesn't actually matter where it is. So say y could be right here, it can be right here, or here. The computer doesn't actually care. By default, most things are stack, but there's also heap options. Let's say you have x and y, and then several other variables. Eventually you're going to run out of memory. The computer will slowly overwrite things. If you're not using x anymore, it can override it with something new that you're using. This also has to do with allocation and deallocation memory. Say you're telling the computer that you want to use y, it allocates that spot to y, and then when you're done with it, it'll get rid of that spot for y, it'll deallocate the memory. Stack usually does that by default. If you're using heap, since you're using random spots, the computer itself usually isn't keeping track of what you're doing, so you're going to have to tell the computer where to assign it and where to delete it basically afterwards. And along with that memory topic about memory, there's pointers and references. Usually in most programming languages, a pointer is usually represented as a star or an asterisk, and a reference is usually an and or an ampersand. Usually people talk about how these are kind of complex topics. They're not very complex as soon as you can understand the memory. You understand the memory is right here, where the values are in it. Say this one's x. So the pointer is basically just saying this is where x is, and the reference, say x is 30. The reference is going to say this is the value of 30. So say you have an integer x equals 30. If you were to do right over here, a pointer of x, it's going to tell you the location of x in the memory, and this will be usually some sort of hexamal representation. Yeah, that's basically just a way to represent the coordinate in the memory, basically. And if you're to do an ampersand of x, it's going to be able to get you the data itself. So let's say if you wanted to reassign something, you can reassign things based on either their pointers or their references. It can be a little bit more complex than this, but this is basically all you need to know. But that's everything that we're going to be covering over for memory, I believe. So now that we know all this, there's a lot of basic commands in many programming languages. Some commands could be for outputting something. Say you have your screen and you want to write to it. Usually this is referred to as print, but there's a lot of other options for saying something. But one basic thing that most programming languages have is printing hello world. And when you do this, people say this is the very basics for learning a language. That if you can get your program to print hello world, then this is kind of the first stepping stone of that. So we're not really going to discuss how this works exactly, but basically whatever your print command in your language is, this is going to display it. Usually this will display it to your terminal, such as right here. This is shell. I just do hello world. And there, it just prints it like that. So usually in order for you to run something, anything you run will run to your shell, your terminal, or your command prompt or whatnot. So most of your output will usually be in this as well. Unless you have some sort of graphical environment set up or some sort of a, like GUI, or some sort of a, it's outputting to a file or something like that. So that's basically how printing works. Or that's not how it works exactly, but that's just what people refer to when they talk about hello world. So now we're going to talk about data structures. Data structures is basically a way of organizing things. You can say you have your integer in x, and then say you also have an integer y. There's a few different ways we can organize this, but we're basically going to say these things go together. So now let's try to set up ways to organize things. One concept of data structures that's very popular is an array. In many languages it can be called differently. A similar thing is a vector. A vector and array aren't the exact same thing, but it also depends on the language, but they're very similar. Another one is a list. But basically all you need to know is that this array, vector, list type basically just puts things in an order. So let's say you have this array, let's call it names, and this array also, we're going to tell it it's a string. So it's an array of strings called names, and basically the names, you can just assign things to it. You can add into it my name, you can add into it Joe, and then Mike. So basically all these names are added into the array. This usually works the same way for a list or a vector. One idea though is to note that an array by default, usually when people talk about it, has a default size. So right here we have 3 names into it. So if our array was the size of 3, it would work. If our array was the size of 2, it would give us an error by putting in more. A vector on the other hand usually grows, but also like I mentioned, this changes based on the language. But say the vector doesn't have a size, and then you pass in Avery to it, and then you pass in Joe, and then you pass in Mike, and it grows as you do it. Now let's say that we know all these names are in here, and we want to get the second person in the name, we can just do names, and the usual syntax for it is going to be the square brackets, and it'll be 2. And 2 will refer to the second one. Although in most programming languages, most things start at 0 and then go up. So this one would technically be 0, and this one would be 1. So this one right here would be 1, and that would refer to the second one. But this also depends on the language, but this concept of starting at 0 first is what most languages do. So let's say if you wanted to print out name, you can just do print names, and it'll print out all this. If you just want to print out a single name, you want to print out my name, it's just going to print out this first one as such. And let me delete all this. A few other concepts with this is like a matrix, where something you might learn in math. It's kind of similar to the other thing, where the list was something like this, where this is the list, where this is like that's 1, 2, those are the spots. This is a list of integers. A matrix can be organized a little bit differently, where they're set into a grid formation. Not every language has something like this, but they can usually be made. Or you can also make an array of arrays, so let's call this one as an array right here, and then array in it. So let's say there's a big array right here, and then in each one of these single arrays there's an array in it, basically, of data. You can use this for storing like coordinates or something, or storing a grid, where this in the end is basically going to work the same way as a matrix. Another option is a dictionary or a map. They're not the exact same thing, and they're different in different languages, but they work just like how you would think a dictionary would work. Well, let's say you have a word, and then you have the word's definition. And then you can just repeat that for different words and different definitions. And this can be a dictionary or a map in some cases. It doesn't even always have to be a word. It can be any sort of thing you want. You can do x is 30. So anytime, let's call this map m. So anytime you refer to m, x, it's going to know you're talking about 30. And let's say this right here is k. So anytime you refer to m, k, it's going to know that you're referring to this. And in some languages, you might be able to even refer to this to get this back. But that really depends. Not all languages have this exact same concept, but it's the general idea is there. We also have to talk about operators. Like I mentioned before, you can do simple math. So 3 plus 3 equals 6, and these are operators. But there's other kinds of operators as well, and I don't mean just by division and multiplication. Those are as well as are included. But let's say you want to compare something. You want to say, is 3 the same as x? To compare it, instead of using an equal sign, most languages have this, a double equal sign, and that'll just tell you if it's true or not. And in some languages, it might even say equals. It really depends on the language, but that's the general concept of an operator. It's the same way you do in math class. It's going to say it's greater than, so it's going to let you know, or something like this or this, except for it's going to be written out like that usually. And that'll basically is an operator to tell you to do something. There's also operators where you can do math. So you can do x plus equals 1. So let's say x is 3. So now the plus equals is an operator used in most languages, where now x is going to be equal to 4, where it plus and then equals 1 adding to it, instead of doing x equals x plus 1. And then even in some languages like C++, you can do plus plus, and that plus plus just refers to adding 1 to it. And the same concept could be done for multiplication and division. So you can do something like x equals times equals 3. So for x were to equal to 3, now it's going to multiply it by 3 as well. So it's going to be the same as x equals x times 3, which is going to be 9. And that's going to be done with a division and basically anything else like that. And these are the basics for operations, basically, where you can use not just the plain operators that you usually might know from class. Sorry about my handwriting, but I think you guys can tell what I'm trying to do. Let's go back to the other example. We do x equals 30. So now how are we going to check this? This is usually referred to something as an if statement. So we'll do if x equals 30, and then if it does equal 30, we're going to do something. And then if it's not 30, we can usually use an else statement, and then we'll say, now do this. Another operator usually is an exclamation mark, which means does not equal. And this sometimes can be used for other things. A different variable type, I think I just realized that I forgot to mention, it's called a boolean. A boolean is true or false. A boolean is also binary, where it's ones and zeros, where true is 1 and false is 0. It depends on the language, but that's usually how it works. So in this case, x does not equal 30. If it returns that it doesn't equal 30, that means it's true, so it's going to return a true. If it's equal to 30, then it's going to return a false, and basically that's what it's going to do from here. But a boolean is a variable that can store true or false, and it's also the same way that an if statement will work. Let's say this first condition doesn't work for x doesn't equal 30. We can test something else. It'll be else if does x equal 40, and we'll do that. And if it finally doesn't work, we can do another else statement, just saying, if nothing else works, just try this. And that's how basic if and else statements work. Now that we know a lot of basic stuff, we're going to go and talk about functions. Here's a function that you'll know in math class, y equals mx plus b. And this is for a line basically, where that's slope and that's the x, and b is usually the y at 0, and it's going to return y where it is. So in math, how functions work, programming functions work the exact same way. We're all, in this example, all of these are going to be integers, or they could be a double or a float, but we'll just say these are all numbers basically. They're not going to be strings. And say we want to have a function, and we can call this function right here. The syntax for it is going to be different in any language, but we're going to have this function, and we can call it a line basically. And in this line, we're going to want to pass in these values, and these are parameters. So you can usually represented as a parentheses, but we're going to pass in m, x, and b. And then in here, it's going to calculate m times x plus b, and usually a function will return something. So we're returning m plus x plus b, and we can even just write y is equal to that, and we can return y. So anytime you want to calculate this formula right here, this is how the function would work, where you'd pass in the parameters, it would do the calculation in the function, and then it's going to return it. Oftentimes a function, you're going to have to tell it what thing it's going to return. So instead of just saying it's a function, we can say it's going to return an integer, and we'd also want to tell it that these are integers as well. So it knows it's returning an integer. The function's name is line, so equivalent to doing y equals 0.5 x plus b plus 10. We can say we know this x also is going to be equal to 1, so we can do our function where y equals line of 0.5 1 10, and that's going to work the exact same way. So that's how a function works basically. It's just you pass in parameters, and it does some basic math, arithmetic, and logic inside of the function with those parameters, and then it can return something. A function doesn't always need to have parameters. It doesn't always need to return something. Sometimes you can just call a function to do something. A function for hello world, you can just call HW, and anytime you call the function hello world, it's going to print out hello world. So it doesn't always have to have a parameter or a return as well. Now that we're doing a little bit more complex stuff, we're going to talk about syntax a little bit. In most programming languages, a block or something like this, it's going to be a curly bracket, and a block is basically, let's just say, our function. It's going to be defined out here. That's going to be function line, and anything inside of that is going to be in here. So our math and our return statement is going to be in here. And then our parameters are usually in parentheses. Parentheses also, you can use them the same way you do it for math, but parameters parentheses. Another thing we mentioned earlier is this square bracket. It's usually pointing at something in a list or something like that. It's not always the case, but that's one of the main uses for it. But this right here is basically just to keep things inside of it. And in most languages, lines end with a semicolon. That's not always true either. So you might want to add a semicolon here and here, but it depends on the language. Same thing works for if statements. You can do if something, then you do it in here, and all your code's going to be in here. In a lot of languages, I believe most, you're going to have to put the if statement in here as well. So if x equals 30, though not in all languages you'll need the parentheses, but that's a thing in most languages. So whenever you want to learn a language and pick it up, one of the best things to do is learning the syntax. It's one of the main things that makes a language stand out from other languages, because other than that, most of the concepts are very similar. And now we're going to talk about iterations, basically just doing something over and over. Say you want to have a program repeat something just over and over again, like a clock. You want a clock to always add 1 second every single second, and that's simple, just like that. For that, there's a few different things that are called, different types, I guess. There could be a while. In a while, we'll take in a parameter, and this parameter will basically just be like an if statement. It'll be if true or false. So it's going to be while x equals 30 for this example. And as long as x equals 30, it's going to repeat anything in here. So a different example of x equals 30, we can do x is greater or equal to 30. So we can say int right here that x equals 50. And then down here, we can do x minus equals 1. So right here, it's going to repeat, and every single time x is going to be decreased by 1. So as long as it's greater or equal to 30, it's going to work. But as soon as it's 30 and then it minuses 1 and goes to 29, it's going to leave this while loop. So this is a loop, it's iterating through it, and that's the basic concept of it. While loops are usually, like we mentioned, they're using they're checking something for true or false. There's other ways of doing something like that. It's usually referred to as a for loop. It'll be for, and then usually you'll give it something, you'll say until something, and then what to do every single iteration. So we'll do like I equals 0 as one thing, and then you can do I repeat until it's greater than 30, and then you can do I plus equals 1, and then anything will be in here. So basically it's going to set it to 0, it's going to repeat it until it gets to 30, and it's going to increase I every single time, and you'll just put it in anything that you want to be repeated 30 times inside of here. Another thing to note about syntax as well is a lot of programming languages, at least some of them, they care about spaces and tabs. So when you're organizing something, say you have this while right here, and then you have the parameter, and then you have this. Let's say this right here is right on with your file. There's no spaces. A lot of programming languages will want you to have some sort of tab right here or some sort of space. And some languages also want you to be consistent. So let's say this one's just 1 space. It's going to want this one to be 1 space as well. But this really depends on the languages. Python has some stuff with that where it really matters, but like in C++, it doesn't really matter. One note of that is because C++, like for the if statement, like it's going to need to know more stuff like this, but in Python you can just do like something like this, and then you don't need these brackets, you can just do right there. So because you don't need the brackets, it really matters about the indentation. Let's say you're in a while loop and you want to escape it, but it hasn't met the requirements. One thing you can do is called a break. A break will, this is the main thing and used in most languages, it'll leave whatever you're in. So we're inside the while loop, so if you call break, it's going to leave it, and then it's going to continue just from anything after it. Let's say you want to exit your program, similar to a break, you can just call something just called exit in most languages. You might even want to pass it an error, so you can say -1, and we just know what -1 equals. So like you can have a list of errors, and you can call exit for different reasons. And that's used in most languages. Instead of a if statement, sometimes there's something called a switch case, where it'll be a switch. You can give it a value, and it'll have case. So let's just say like a switch for x, and it'll be x equals 30. Do this, case x equals 40. Do this, and then let's say there's no options. You can do a default, and then it'll just do this. So if it doesn't equal 30, doesn't equal 40, now these are going to be double. It doesn't equal 40, then by default it's going to do this. Most languages have something similar to this. Also, most languages you're going to want to break as well, because if you don't break, it's going to check for the next one. If you don't break here, it's going to check for the next one, and it's eventually going to get to the default one, so then it's going to do that one anyways. This is something we're going to talk about that we've already been talking about slightly. It's a scope, basically. It's the main term for it, but it's kind of what keeps track of things. Say we have our while statement, and it's basically like a block. So this is the while, and then say after the while we have a for loop, and then after that we have a if statement. So each one of these is their own scope in a way, where the while loop has everything inside of it, for loop has everything inside of it, and so does this if statement. But sometimes you can have a scope that's greater than all of this. Your whole entire file or your whole program as a whole is usually referred to as the global scope, or where everything is global, everything's inside of it. But these scopes have a lot more options, where basically one thing of doing that we mentioned earlier, say we have an int x and an int y, you can create a scope which is called a structure, and the structure is going to store both of these. So anytime you have a coordinate of x, y, and z, and say you want to not just have x, y, and z, but you want to have a vector 3D, and that's what you're going to call it, structure vector 3D. It's going to store all this into the vector 3D. So anytime I'm going to create a new one, you can just call it vec3d and say this is like a player position in a game. You can call it player position. And now whenever you want to access any of its coordinates, it'll be player position dot x, and then it'll be the same for the other ones. And this is a structure basically where it just stores multiple things together. It's different than a list or an array, but it's a similar concept of trying to organize your code. A different type of structure is called a class. Most programming languages have this. A class is basically the exact same thing as a structure, except for they're more known for not just storing variables, but storing functions. So let's have a class that has an integer x and an integer y, but it'll also have a function for moving it. So you can do like move, and you can pass in an x and a y. And this function will basically just change x and y. So you can call this class player, something like that. Usually you want to create a player, so we'll just do player p, and it'll just be like p.move, and then 3, 2. So there's something like that, where now you're going to be able to reassign stuff. And these are on different lines. It's supposed to be semicolon. But yeah, so you create the player, and then you create this down here. So this right here is going to be the name of it. That's what this is right here. It's not an actual instance. You create an instance by calling it p right here. And the same way it works for a struct. Like we had that struct vec3d. We also had to do vec3d player position. So it was a struct vec3d. And then we created it right here. That's called instancing something. And that's creating it basically. A lot of times there's a concept of public and private, or basically says what has access to what. Say you're in the exact same scope as something, anything in that scope is public to you. But if you're outside of that scope, you're in a different, say you're in a greater scope, or to say you're in a different scope down here, to be able to access something from here, it has to be public. If it has a, say that move function will be right here, but the integer for the x and y will be down here. So inside of this class for the player, he can change the x and y, but outside of the class, say you're out here or you're down here, he can only call the move function. He can't change the x and y himself. And that's basically just make it so like nothing gets changed without you knowing it, and your way to like make it so things work the way you want them to work without giving sort of errors. Like I mentioned, your main program as itself, it's global. In some languages, it can be called a namespace. The namespace will kind of cover everything. By default, the namespace is global, but you can also have a namespace inside of it. You call it a namespace game, and all your stuff for your games can be in here. You can have structs in here, you can have classes in here, you can have individual variables and functions. Classes themselves can even hold structs, they can hold everything. So anytime you want something outside of that, just to organize more things, you can use a namespace or something like that. Another type of thing similar to a struct is an enum. An enum is basically the exact same thing as a struct. It's just for storing stuff. A lot of examples you see about enums, they're using colors. Well, they'll be like, oh, an enum is going to store the color red, green, example. But it kind of just works similar to a structure. A lot of things, such as a class, whenever I say you initialize it, so like player P, whenever you do this, it creates this P of a player. And there's some options in some languages where you can have a constructor and a deconstructor. And a constructor will basically say, whenever you say player P, when you create this P, it's going to run anything in this constructor function. And whenever this P is destroyed, say the application closes, or you tell the computer to end this, remove it from your memory basically, it'll call the deconstructor and it'll do anything that you have in the constructor or deconstructor functions, which are going to be in the class themselves. Another concept is error handling. In most languages, error handling is done using something called try and catch. Basically where you want to try something, if it works, then it works, and then you catch an error, and then you can basically like print out the error and say what happened. Something called, there's throwing and exceptions, but a throw can basically be, say you're going to try a function of the move function, and in our move function we can have a throw option where to say like if x equals 50, we can do throw out of bounds. So now if we call the move function in our try and say we're going to pass in the parameters, sorry I can't really read this that well, but it's going to basically like move 51 10, and it's going to call that, and now it's going to say, well, x equals 50, so that's going to throw an error out of bounds, and basically whenever it goes to print out the error, it's going to print out that out of bounds error. It's a little more complex than that, but that's how most languages do it, just trying and catching. You can use it just to make sure that everything's working. I believe that we've covered everything that you would need to know to learn programming, where we can look at an example for, I guess we can create a function. We can call this function square root, just refer to as this, and then we're going to pass in an integer of a value. Let's call this value v, and then we're going to have this right here. This main example, it's not a real language, but it's pretty similar to C++. If we were to remove this, we can just say integer. That's how C++ is going to do it. And now, so it's going to return an integer as well. And the square root, let's say you have a different function called power, and the power is an exponent function. It is, you give it the bottom and the exponent right here. So the square root is also just going to be like v to the power of 1 over 2, if I remember correctly. That's how square root works as well. So we can just return this. So this way it's a function calling another function where it gets this, and that's how you calculate square root. I could be wrong about calculating square root, but that's just an example. Another thing to mention is libraries and things like libraries. One example, I guess, to explain what a library is say for that power function that we didn't use, let's say power function isn't created by us, but it's in a different file. This is created, let's just say it's created by someone else, so we downloaded this or it came with a computer. So the library would be this file. This file will store anything else that a program can store. So anytime you're in your program, you want to use the function power, you're going to want to tell your program to include power, except let's say that the name of this library is math. So instead of power, we want to include math. This also has different names, such as import math. Depends on your language, but basically you're just saying it to include something else. This is used a lot for math. This is used a lot for input and output, such as that print statement. There's a few other things like print. Also, if you want to read something in, if you want to even read in a file, or if you want to create a new file, or if you want to do stuff with the internet, a lot of these things use libraries, using tools that other people have created. If you want to make a window, if you want to do art, or if you want to do graphic stuff, you want to use a game, if you want to be able to read keyboard input or mouse input or anything like that, you're going to want to use a library. But a library in the end of the day is something that someone else has created using the programming language. So you can usually do all the stuff yourself, except it just makes it less complex for you. There's no point of you having to rewrite things that have already been written. Outside of including it just in your file, you'll say like include math at the very top up here. We're going to talk about a different way that you're going to have to do sometimes depending on it. But with that said, we're going to be talking about compilers. A compiler is basically what takes your program, x equals 30, and converts this into binary. I can't think of binary off the top of my head, but it's converting it into something that the computer can read. Usually a compiler will actually compile it into assembly, where assembly is like a really basic language by the computer that's then converted into binary itself. All languages are compiled languages. Some people will have different terms for them. C++ is a compiled language where anything that's in your code in C++ will be compiled into usually assembly and then into binary. Whenever your compiler, you give it your code. It can be one file, it can be multiple files. And then also, like I said, with including a library, sometimes you want to tell your compiler that you're including that library. So you want to tell it it has your file, and then you're also going to tell it that it has the file to the library as well. And basically the compiler is going to take this, it's going to convert it into binary, and then it's going to give you an output of something that you can run. And now this output is going to be runnable. There's also interpreted languages, but interpreted languages are as well as compiled, because it has to be compiled to run, because the computer can only run binary. But one language is Python, where instead of compiling it all at once, instead of creating an output, it actually looks at your file and it will look line by line. At least that's the main concept, where it'll look at the first line, it'll convert that to possibly assembly first, but in the end it's converting to binary. Then it's going to run it, and then it's going to look at the second line, it's going to run it, and the third line, it's going to run it. That's the main concept of it. Of course, it uses the same memory, so if you have a value up here, it's going to know that value's down here as well. Some people can say that Python and other interpreted languages could be slower because of that. At the end of the day, computers are really fast. It doesn't matter too much. And also, at the end of the day, they're all being used by the computer, so they're all being compiled into binary. But people call them compiled languages and interpreted languages, because compiled languages, to run something, it's compiled first, interpreted, it's interpreted line by line, or usually. Sometimes you want to have something in your code that's not actual code. This is referred to as a comment, and some languages can be like this, or like this, where you can just write anything in your code, just to leave a comment to it, leave a note, a reminder of something that you want in your code. And this is usually the way of doing it. There's such thing as comment blocks, where you can have, like, that's an asterisk. It depends on your language. Like I said, there's a syntax for it, so you can have everything in here. A comment block could also be multiple lines, so let's say this is the beginning of the comment block. Let's get rid of that. And this is the whole entire block right here of the comment. There's a lot of tools out there for creating documentation, where you can say you have your program, it's code, you pass it into the documentation program, and it'll create documentation, and it can create PDFs, it can create websites showing off your code, and it does that by looking at your code and looking at the comments and looking at a few other features that it'll require you to have in your comments to generate this. I have a few other videos talking about using Doxygen, which is usually used for C++ and C, and also PyDoc, which is for creating documentations for Python, so check those out as well. I'll probably have another video coming out soon using documentation for Go, even though that's probably one of the simplest ones out there. Another thing to talk about is debugging. Debugging is basically just testing your program. You want to make sure it works. So one thing to do with that, let's say like we have our function move. One really basic way of debugging it is anytime you pass an x and a y, we can print out that x and y. So that's just going to be one way of debugging something. So you can basically, if there's ever an error, if you want to figure out what the error is, you can just have it print out a bunch of your values. That's a really simple, little bit complex way of debugging something. But that way you can actually look through how everything's working and see how they're working. There's also debugging tools. I have a video, I believe it's on LCOV. It's not exactly for debugging, but it's seeing how your computer runs. There's something else called GDB, which is for debugging, but they're all for different languages, so you need to find a debugger for looking through languages. If you're not going to find like an actual debugger for that language, the best option to do is just printing out anything you can. If this is the first time ever programming, you're going to need something called an IDE. An IDE is a sort of integrated development environment, I believe. It's basically a text editor where you can write in all your code, except it has extra features. It'll highlight syntax. It might even show you errors in your code, and you might even be able to run your code from the IDE itself, and you might be able to compile it from the IDE itself, and have like your projects. You can have multiple code at once. You can probably be able to tell your compiler in the IDE which libraries you're going to include, but you can also do all this stuff just from any text editor. You can use it from your terminal. You can use it from Notepad++. Some people might hate you for it, but it doesn't really matter. There's almost no difference. I don't know about Notepad++, but like I use a gedit on my computer, and it highlights and does syntax stuff. And plus, when you do compile it from the terminal, it's easier, at least for me, to include any library that I need. And it also just tells you where the error is, and you can just look at it in your text file as well. Because I usually just do it all from the terminal anyways. But an IDE is popular. One popular IDE is VS Code, Visual Studio. It's made by Microsoft. I can't remember, there's another one. Maybe it's just called VS, I'm not sure. But that's an IDE. It's a little, like a less complex IDE. Another one that's popular is Atom. There's also Sublime. These are just basic ones. There's other ones that are more specific for languages. There's IDEs that are made specifically for Java. There's IDEs made specifically for Python. And tons of stuff like that. Even if you want to program in R, R is a little bit different than some of the stuff we've been covering. At least it's less complex. You can use RStudio. That's an IDE for it. But yeah, so if you're interested in IDE, I would just check out VS Studio, or check out Atom. If you want to do it from the terminal, I would suggest VI or Nano. If you're an absolute beginner, I would use Nano. VI, you kind of just need to learn a little bit more commands, as some extra buttons and stuff you have to press, because from the terminal you're not using the mouse, so anything you want to do is going to be through extra commands and whatnot. One way of organizing code, of course you're just going to want it like in your folder, but let's say you make some changes to your code and it doesn't work and you don't remember what you changed. One popular option is Git. Git basically takes your code and it saves it into an older version. The older version is basically all stored with other older versions. With their changes, you can leave a comment, or well, I guess a commit, but it's basically like a comment saying what you changed. By default, Git's not going to store your code by every single time. So anytime you make a different major change, you just want to tell Git to store your code and say what you changed. So that way you can keep track of anything. Git is Git's a revision control software basically, but it's basically, I guess, it's just for keeping track of stuff. There's a website called GitHub. There's also a website called Bitbucket that will keep track of your Git, and you can upload your code to their servers basically. But at the end of the day, Git's just a tool. It can just be ran on your computer. And I guess I can show you what it really is. It's a stupid content tracker. But it's a revision control system, and basically all the commands are in here. You need to look at the man page to learn how to use it, but if you think it's a little bit too complex, I would just suggest using GitHub or Bitbucket as well. Another concept or ideas, this is the very last thing, is program paradigm or program style. Most programmers will program in OOP, or OOP. It's object-oriented programming, or basically an object is what we looked at was a class or a struct, where you're using this object and namespace and whatnot to be the way to organize your code. There's other programming stuff such as data-oriented and functional programming. Functional is based on where your main way of organizing is using functions. Data is a different way similar to it. We're not going to be covering any of this. I just thought I would mention it, that there's different ways to write code. So if you see people doing it differently than you, you don't need to worry about it. But even then, I would just say to Google it. There's tons of websites. If you ever have any questions, you can look on YouTube as well. If you have any major questions, leave in the comment section below as well. Hopefully you guys enjoyed today's video. I really hope this is useful for anyone. I know that this would be useful for me for whenever I got started. If you have any questions about any of the concepts, or if you want to point out something I might have missed or something I might have talked about wrong, I know some stuff I didn't really talk about specifically was the memory stuff and like the pointers and references and heap and stack. I could have talked about a little bit more, so if you guys are interested, let me know. Like I said, the IDE, I would just look up VS Code, or you can look up one specifically for your language. Once you learn one language, you can easily pick up any other one. You just need to learn the syntax, and you need to learn the default functions for that language and the default data structures. Like I said, some languages have an array, some have a list. They all have different names, and then some of them work a little bit differently. Once again, thanks for watching. If you guys are new here, feel free to subscribe. Leave a like. I really appreciate it, and see you guys again next time. Bye.